This next video is about measures of variability of discrete random variables. And what I'd really like you to do is watch a video link that I've put on our Schoolbox page called Measures of Variability. It talks about three things. It talks about range, it talks about standard deviation, and it also talks about variance. It talks about it more generally. It gives a formula which is interesting. It's not really on our course, but it's worth knowing. But it also explains in a practical sense, why we use these three things to measure out how spread out the data is, the spread of the data, how variable it is, etc., etc. So a good way of really coming to terms with these, especially these two, not range not so much because it's not that important to our course, but certainly the bottom two, a good way of doing that is watching that link on Schoolbox, Measures of Variability. It's about a 10-minute video and it explains it really well. I searched hard for ones that pitched it at the right level, and I think that's the one to look at. So it's in the links section on Schoolbox. Okay, so here we're talking about variance, and it's related here to discrete random variables. But variance generally is a measure of spread or dispersion. How dispersed something is, how widespread it is. In discrete random variables, you often see the symbol var x. Okay, it's also denoted by the symbol sigma squared as well. You sometimes see that. So they're interchangeable. They'll appear from time to time in exams and also in the work that we do in class, but they mean the same thing. The formula for working out the variance of discrete random variables such as x is what we call e of x squared minus e of x all squared. Two different things. And explain how that works, let's do an example. Find the expected value and variance of the following probability distribution table. Alright, so to work out the variance here, we have to work out two things. We have to work out e of x and we also have to work out e of x squared. First things first, let's work out e of x. And as we've always done, it's multiplication of the x values with the probabilities and summing those together. So 2 times 0.12 plus 3 times 0.24 plus 4 times 0.37 plus 5 times 0.12. And if we sum those together, we get 3.19. Okay, so that's e of x, and we'll just put that up here a little bit. Just out of the way. So we've calculated that there, e of x. Okay, now let's look at e of x squared. Now we haven't done this much so far, but here what we do this time, instead of multiplying x by the probabilities, we multiply the square of the x's by the probability. So it's 1 squared times 0.15 plus 2 squared times 0.12 plus 3 squared times 0.24 plus 4 squared times 0.37 plus 5 squared plus 5 squared times 0.12. So squaring the x values, multiplying them by the probabilities, and that's going to equal 11.71. Okay, so we can just put that over to the side as well. Alright, so once we've found those two, e of x and e of x squared, then we apply this formula here. There it is. So var of x, the variance of x, equals e of x squared, which is 11.71, minus e of x, 3.19, squared. So var of x is going to be 1.5339. Okay, to 4 decimal places. Now, we haven't done standard deviation yet, but I just want to point out at this stage that the standard deviation equals the square root of the variance. So if we calculate that, we'd also get the standard deviation. Okay, the variance of a linear function. You might remember our expectation theorems, and remember that e of a of x plus b, okay, was a times e of x plus b. Okay, different situation though with variance. Okay, and I've wanted to put that one at the top there because I wanted to contrast the two. If I just highlight this one here, okay, variance of ax plus b equals a squared times the variance of x. Notice how the b drops out. That's a big difference. And I've had, in past experiences, I've had students get those two confused. So please, one's for expected value, one's for variance. But notice how with the second one, the b drops out. So find the variance of 2y plus 1 for the following probability distribution. Okay, so if we look at that, and I'll put the formula up there for you to look at. First of all, before we can do that, and I've also, just to change things around here, I've used y instead of x. It's worth doing that because our variables can be x, y or z. So I thought we'd just use y, just to show you it's the same sort of process. So the first thing we have to do here, to be able to use this formula, is we're going to have to find var y, so the variance of y. Okay, so I've gone away and done that. I've calculated var y, so to remember to do that, I had to calculate e of y, expected value of y, expected value of y squared, so I've done that there, and then I've applied the formula, so it's expected value of y squared minus expected value of y all squared, and that's 1.1275, whoops, that's 1.1275 there. So that's var y. Alright, now we've been asked to find the variance of 2y plus 1. Okay, so in other words, what we're trying to find here is var 2y plus 1. Now, if we want to apply our formula here, that means that's the same as 2 squared var y. Okay, notice how the b disappears, and the b in this case is the 1. Okay, the 2 pops out the front and gets squared, so that equals 4 var y, and that's going to equal, if I multiply 4 by var y, which is that, I might just get rid of this now just for the moment, just get a bit more room. Okay, so that equals 4 var y. Var y we know is 1.1275, so it's 4 times 1.1275, and that is 4.51. Okay, so that's how we apply that theorem to find a more complicated expression there, var 2y plus 1. Alright, if x is a discrete random variable with the following probability distribution, find the value of k, a positive integer, if the variance is 1.7475. Wow, big question here. So, what we need to do first of all is find the variance, okay, and then we're going to make it equal 1.7475. So let's do that. Okay, and to find the variance, first of all we have to find e of x and also e of x squared. So I'll go away and do that, and we'll come back in a sec. Okay, of course, to find the variance, we have to find e of x and also e of x squared. So that's what I've done here in this situation. To find e of x, I've multiplied the x values by the probabilities, there and there and there. And that gives you a grand total of 4.35 plus 0.1k. And to get e of x squared, I've squared the x values to multiply by the probability. So instead of 3 by 0.15, it's 9 by 0.15, 16, 4 squared is 16, 6 squared is 36, and we've got k squared there. So I've squared all those x values there at the top of the table. And that gives me, for e of x squared, 22.35 plus 0.1k squared. So I've copied that over to the next slide. There's our e of x, and there's our e of x squared. Now, of course, the formula for variance is e of x squared minus e of x all squared. And that's tricky, because e of x all squared, which we're going to work out now, is going to be 4.35 plus 0.1k all squared. So if we multiply that out, what we get is this. We get 0.01k squared. Okay, and that comes from 0.1 times 0.1. We get plus 0.87k. That's by multiplying those two together and doubling it. Okay, you can do that on a calculator. Plus 18.9225, which is also done on the calculator. And remember, you can expand those sort of things on the calculator anyway, but it's up to you which way you do it. Okay, so that's e of x squared. Okay, so then what we need to do is apply the formula. So var x will equal e of x squared minus e of x all squared. Okay, so var x, remember, is e of x squared minus e of x all squared. E of x squared is that, back up here, and e of x all squared, okay, is going to be that guy there. So remember, because we're minusing it, we have to minus all three parts of it, the 0.01k squared, the 0.87k, and the 18.9925, and it's always handy to put those in brackets, which forces it to subtract all of them. Now back to the question, we know that var x, we haven't used this bit of detail here yet, we know that var x is 1.7475, okay, it's going to equal all of that left hand side, which is going to be 0.09k squared minus 0.87k plus 34725. Sorry, that's should be 4275. Now I've missed out a few steps there, but you can use your calculator to work this out. But I've tidied up that whole right hand side there. Okay, all that along there has been tidied into 0.09k squared minus 0.87k plus 3.4275, and I've made that equal var x because from the question we're told that var x equals that. It looks like a quadratic situation, so we need to get everything on the one side. And to do that, if I just go to the next slide, we're going to get 0.09k squared minus 0.87k plus 1.68 equals 0. Now we can solve that on a calculator. Use your algebra menu, solve. Don't forget to put the comma x. Another way of doing it is if you multiply everything by 100, you actually get 9k squared minus 87k plus 168 equals naught. That can actually be factorised into 9k minus 24, k minus 7 equals naught, k equals 24 on 9, or 7. K must equal 7, since the variables are discrete, so we can eliminate 24 and 9, so k equals 7, since the variable is discrete. Okay, so there we go. The value of k equals 7. Let's go back to the start. There was our question. So the first thing to do, we knew the variance is 1.7475. So the first thing we had to do was work out the variance. To work out the variance, we had to find e of x and e of x squared. Once we do that, we have to subtract e of x squared minus e of x all squared. E of x all squared there is tricky, so I had to multiply that out fully. Then there's that subtraction. That bit there is e of x squared. That bit there of e of x all squared. Tidied that up. I've substituted in the 1.7475. That comes from the question over here. Okay. Formed it into a quadratic. We could use calculators. You could use calculator all the way through this. Okay, so I'm doing it a lot without, but there's a lot of opportunity to use calculator. Lots of different spots. Factorise and then eliminate 24 and 9, and we've got our answer. Mentioned before about standard deviation, SDX or sigma, and standard deviation is the square root of the variance. Variance and standard deviation are used extensively in many real-life applications involving statistics, and I encourage you once again to look at the link I put on Schoolbox for that. Here's an example. A toll is introduced on the Eastgate Bridge, and if your car contains no passengers, you pay $2. If your car contains one passenger, you pay $1.50. If your car contains two passengers, you pay $1. And if it's greater than 2, 3 or greater, you don't pay any toll. Long-term statistics show that number of passengers X follows the probability distribution given below. Okay, so 0.4 chance of no passengers, 0.35 chance of one passenger, 0.2 chance of two passengers, only a 0.05 or 1 in 20 chance of them being greater than or equal to 3 passengers. So there's the long-term statistics. Construct a probability distribution of the toll paid. Find the mean toll per car. Find the standard deviation of toll paid. Let's get into it. First thing we have to do is construct a probability distribution of the toll paid. Now, we're given this information over here on the right. No passengers, $2 toll, one passenger, $1.50, etc. So to create a probability distribution of the toll paid, all I have to do here is rub out the number of passengers and change that column there. So instead of number of passengers, we're going to change that to in fact, what we might do here, I might actually change the variable altogether. So I'm going to rub out a lot here. I'm just going to leave those probabilities here. And what I'm going to do is call the variable, now instead of number of passengers, it's y equals toll paid. Okay, that's a new variable. So instead of putting x up here, I'm going to put lowercase y and the probability of y equaling y. Okay, so we know that the probability of there being no passengers is 0.4, therefore we replace that with $2. Probability of one passenger is 0.35, so we're going to put 1.50 up there for $1.50. The probability of there being two passengers is 0.2, change that to 1. Actually we can just put 1 for that. And probability of there being 3 or more passengers is 0.05, so we're going to put 0 there because there's no toll. So straight away we've converted that into a probability distribution for the toll paid. To work out the mean toll, and that's the same as E of y, we do it as per usual. That is E of y equals 2 times 0.4 plus 1.5 times 0.35 plus 1 times 0.2 plus 0 times 0.05. So if we calculate that, we get 1.53. Therefore, the mean toll is $1.53. Last thing we have to work out is the standard deviation, which remember is the square root of the variance. We already know that the expected value is 1.53, the average toll. And of course, to work out the variance, we've got to also work out E of y squared. We've already got E of y there. So E of y squared, I'm squaring all the x values, or the y values, sorry, in this case, multiplying them by the probabilities, and I get 2.5875. So now we can apply our formula. Okay, it's going to be 2.5875 minus the square of E of y, which is 1.53 squared. That's going to be 0.261875. And to get our standard deviation of y, sorry. So the standard deviation of y is going to be the square root of 0.261875, and that is to 2 decimal places because we're dealing with money here. It's 0.51, which is 51 cents. Okay, quite a lengthy video that one, but that brings you up to date with variability, measures of variability such as standard deviation and variance. Okay, so chance now to do lots of questions from exercise 10D. We've still got one little bit to do in 10D, so you could probably do exercise 10D. Probably up as far as question 13, so 1 through to 13.